In this video, we will review Competency 17 relating to statistical inference and probability. We will focus on the cumulative distribution function, the CDF, which is a probability that x takes a value less than or equal to the actual x that we desire. On the TI-84, this will be represented as the binomcdf. Number 1. An ordinary die is rolled 20 times. What is the probability that the number 2 will show at most 7 times? Okay, you'll see that we have a visual that numbers 1 to 20. This represents each of our trials, and we're going to use that to kind of make sense if you've forgotten how to do this, or maybe you had a little bit of confusion. Okay, so at most, and we'll get to that first. N equals our 20, and our probability of any die is 1 out of 6. This hasn't changed because this could be 3, 4, 1, so 2 is fine. They're just saying any number rolled on this die. They could have said anything. Okay, so that is 1 out of 6. The trick here is determining your value of x to put into your calculator. Okay, so let's get a highlighter. It says at most 7 times. This means we need these lower tries. We're only concerned with our trials of 1 to 7. Okay, and we are including 7. So x is 7. So we will use our binom CDF as is. And you'll see what I mean by that in a moment. Okay? Second vars alpha apps. And we have 20 trials, 1 out of 6 probability. We're interested in all 7. Enter, enter, enter. And C is the correct option. Okay, number 2. Okay, an ordinary die is rolled 20 times. What is the probability that the number 2 will show at least 7 times? Yes, these two questions are just almost alike. The difference is the words at most, at least. That changes things. So let's get our highlighter and show you those changes. At least 7 times. So we are interested in 7 to 20 trials. Those are the trials that we are going to focus on. This means that we need to subtract out the first 6 trials. And this is because or rather, I'll show you what this means and what it's about. All of our trials, their probabilities must equal 1. If that's the case, we know that's a fact, we will have to subtract out some of these probabilities in order to get what we need left over. So notice the difference in our visual aid. So N, again, is 20. Probability hasn't changed either. Okay? X has changed. We need to subtract these lower options 1 to 6. So we go with x equals 6. Okay. On the TI-84, we must push 1 minus then our binom CDF. Okay. Second vars alpha apps. We have 20 still entered. So enter that. 1 out of 6 hasn't changed. But we don't want the 7 trials. We want 6. Our value of 6 is what we're subtracting out. Enter, enter. And our option is A. Okay, number 3. An ordinary coin is tossed 20 times. What is the probability of getting tails fewer than 5 times? Okay, before we start, let's clean up a little. Okay, all right. So we have n is our 20, and our probability is a coin. So that's 1 over 2. So we need to discover or analyze what is here our x. We say fewer than 5 times. So we fewer than 5 times, we're not including 5. So we need everything below 5. So this means that x is 4. Okay. So second vars alpha apps. Okay, n is 20, enter. Oh, looks like I had this in, but I'll enter it all again. And 4, enter, enter. Okay, and no need to round, and that will be option B. Okay, number 4, a five-sided solid figure has the letters A, B, C, D, E on each of the faces. If the figure is rolled 16 times, what is the probability that a vowel appears more than 6 times? All right, so we have n equals 16, and it's five-sided, and we want a vowel. So that's 1, 2. So our probability is 2 out of 5. Let me write this better. Okay, and we need to figure out what our x is. Let's get our highlighter. It says, oh, we're good here. We need, oh, okay, 6. More than 6 times. We're not including 6. We want all the higher numbers. And when you see that you're using all of the higher numbers, these lower numbers are subtracted out. So this means, think about probability. When we have all of our possible probabilities, these are outcomes that have a probability attached. We add up all our probability frequencies every time these things, a probability of each event occurring. We add them up, they must equal 1. Well, we need to take out a portion of those probabilities. So we know x is going to be 6 here. So we need to subtract. What do we subtract? I'll show you on the calculator, but we will subtract. We're going to say 1 minus our CDF, which is what I have circled. So it's a visual that we're gonna take this idea and put it in the calculator, okay? So 1 minus second vars alpha apps, okay? And our n trials is 16 enter. Our probability is 2 over 5, and we need x equals 6. Okay, it's set up perfectly. We're going to subtract our CDF. Enter, and we have 4, 7. Yes, and the option is D. Okay. Number 5. In a jar of 25 jelly beans, 14 of them are red and the other jelly beans are blue. 10 jelly beans will be taken out of the jar one at a time with replacement. This is important. What is the probability that a red jelly bean will be selected at least 4 times? With replacement must occur with this type of problem. It ensures that our probability is consistent throughout the entire problem. Okay, so we have n equals 10. Oops, let me erase that. Oh, didn't want to erase for a second. Okay. N is 10, and our probability, red jelly beans. So we have 14 of those. So 14 out of 25. What is our X? Select at least 4 times. That means that we need 4 up, which means we need to subtract out our CDF. So it will be 1 minus our CDF. So our X is 3. Okay? 1 minus second var's alpha apps. N is 10. Probability is 14 divided by arrow over 25. Enter. And X is 3. Enter, enter, enter again. And we need to round slightly. And our answer is D. Number 6. 6 cards are drawn from a deck one at a time with replacement. What is the probability that a diamond is drawn at least 5 times? So that is N equals 6. P equals, well, diamond and at least 5. That's important. So diamond, those are 13 out of 52. And we need to figure out what X is. What is X? Okay. At least 5. So that means we're going to include 5. And we're subtracting the CDF from 1 because we need to eliminate those lower values. Okay. 1 minus second var's alpha apps, N is 6. Probability is 13 divided by 52. Enter. Oh, and X is 4. I didn't write that down. Sorry about that. Change my color back. Equals 4. Okay, 4. Enter, enter, enter again. And yes, and we did not need to round. Okay, now with these, I didn't put in the visual. Let's see if we can do it without it. Number 7, it is determined that because of a particular genetic trend in a family of rabbits, the probability of having a male is 60%. If a litter of 4 rabbits is born, what is the probability that at least oh that that at least 2 males are born? Sorry about that. Let me type in if I can get there it is. At least 2 males are born. Okay. All right. Well, we know what N is and we know what P is. So N is the 4 baby bunny rabbits, and the probability of having a little boy is 0.6. No need to use the 0 here. And our X is 2 at least. So if you have 4 bunnies, we're getting, let's see, we're going to get rid of 1, 2, because we have 4. We have 1, 2, 3, 4 baby bunnies. At least 2. Oh no, we're getting rid of more. Now that I say that, that means you need all of these and you have to get rid of those. So we have to subtract those out. So X equals 1. Okay, so 1 minus, okay, second var's alpha apps, N is 4. Our probability is 0.6. And we just need to use X is 1, enter, enter. And great, there's our value, A. That's your probability. That's a high probability of getting a little male baby bunny. Okay, number 8. The probability of getting stopped by a red light at a particular intersection is 16%. If you randomly pass through the intersection 22 times, what is the probability that you will be stopped by a red light 3 or fewer times? Okay. This is a popular problem. I've seen it several times. Okay, so we know what P is. We know what N is given as 22. And our probability is 0.16 X. Stopped 3 or fewer times. We don't need to subtract because we're looking for 3 and everything that's less than 3. So X is 3. Okay, what's the probability of having to stop again? Okay, I think I would take a different street. Okay, second, vars alpha X, and N is 22. N is 22. Enter. Probability 0.16. Enter. 3. Enter. Enter. Enter again. Okay. B. B is our option. All right. This is our third video with this type of probability. We thank you for watching and look out for our next video. That will be geometric probabilities.